Okay, let's have a look at 5 and 6 before we go to the next lesson. So number 5, I want the formula for the area. It's an equilateral triangle. So that means you know that this is 60, this is 60, and this is 60. We'll call each side x. So you know that the area is half the base by the height, or the area is also a half x by sine 60. Yeah, just the two formulas. Now we don't really want the x because the x, it's not something in our final formula. So I think what I'll do is I'll rewrite this as maybe twice the area over h equals x, because I'm just bringing the 2 up and the x down. Bring the h down. So if I rewrite that, I can put that in here, and I get area is a half times 2 times the area over h times 2 times the area over h times sine 60. Now what happens here is you can see that this will cancel this will cancel this. You can check sine 60 on your calculator. It's root 3 over 2, so you get, oh, I knocked my pen out. Hang on a sec. There we go. So we get 1 equals, let me see, that would be twice the area over a h squared sine 60, which is root 3 over 2, I think we said. Yeah. So, oh, wait. So again, this 2 cancels this 2. So we get area equals h squared over root 3, which is the result I have in the question.
But in the question like that, they don't give you the h. They ask the
the answer to be in terms of h. Yeah. They don't give it to you. It's more of a proof.
They give you sides or
No, it would be. It would be like, well, okay, in the exam, yes. In the exam, they'd probably tell you the h. So in the exam, they might say the height is 2 meters. What's the area? Now, I don't expect you to remember this formula, but this is the process to get there. Okay, so write that one down, and then we'll have a look at the last one, 6. Yeah? We can do 6? Okay. So 6, we have this triangle. Ugly. B, and A. And we want to get the area again. Yeah. So we know that this angle, I don't know, we'll call it x, is the same as this angle, and this angle here would be 180 minus 2x if we need to know it. So last time our trick was to use our 2 area formulas. So let's see if that trick works again. We have our height h. So we can say that the area is half the base by the height. And also we can say that the area is a half AB sine x. So that's not really great, is it? I mean, in the last example it was a little bit clearer what to do, but we have many problems here. First problem is we don't know what the x is, so that's a big problem. Second problem, there's a h here, but there's no h here. Whereas I think last time we had an x in both. This time there's no x here, but there's an x here. So we might have to try something different. Any other ideas? Some other formula we could use?
Pythagoras?
Yeah, we could try Pythagoras.
Pythagoras.
Because this is isosceles, we know that this is a over 2 and this is a over 2 here. That it's a mirror. It's the same on both sides. So Pythagoras would say a over 2 squared plus h squared equals b squared. So if we needed to know what the h was, it would be square root b squared minus a squared over 4. Now this is looking quite good, because when we look at the answer, we can see there is a square root in the answer. So this is quite promising. So it makes me think, okay, maybe I should not use sine x. Maybe I should say the area is a half the base by the height. So that would be a half a multiplied by b squared minus a squared over 4. Okay, so we still have a little bit of rearranging to do.
You can't square.
I can't square. Any ideas what could we do to simplify this a bit? Any ideas?
Complete the square? No,
Good try, but not here.
put the square as 1 over 2.
Put the what?
The root square as 1 over 2.
Oh, power 1 over 2. No, not this.
Is it the b plus a over 2 and in the bracket another one? B
Ah, good. No, not this either. Yes?
Divide a with the root.
You have the wrong word, but I understand what you mean. Not divide a square.
Put them all in the root.
Take factor out. Take out a squared. So this here will be b squared over a squared, and this part here will be
4.
1 over 4. What's the square root of a squared? A. So this will be a half a root b squared over a squared minus 1 over 4. So this would be a half a squared root b squared over a squared minus 1 over 4, which is what I have there. Factor out.
Quite similar.
To what? Divide?
No, when you take the a out.
Yeah. I mean, I'm sure there are other ways to get there. I just think this is the quickest. Okay, write this one down, please, and then we'll have a look at the next lesson. Okay, you got this? Yeah, okay. Let's have a look at the next lesson, so. Sine and cosine rule is what it's called. Got this? Okay. What is one disadvantage with sine, cosine and tangent? So last week we saw the formula. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we can use this to find sides or angles, but there's a big disadvantage, a big restriction with these rules. Could I use them on any triangle? No. They only work on what triangle? A right angle triangle. So what we're going to learn today is these two rules called the sine rule and the cosine rule, and what's so important about them is that they work on any triangle. So this is why they're useful. Okay? So the first rule we'll have a look at is the sine rule. So we imagine we have a triangle, and maybe it's right angles, maybe not. So this side we'll call it A, B, and C, and this side we'll call A, B, and C. Yes? Okay, so let's try and find the rule here. So what I'll do first, I'll draw a straight line down the middle here and make a 90 degrees, and we'll call this X. Yes, stop. Sine A, what's that equal to? It's equal to X over C. And what about sine C? X over A. So here you have X equals C sine A, and here you have X equals A sine C. But they're both equal to X. So we can say C sine A equals A sine C. Or you could say A over sine A equals C over sine C. But you can do the same thing for side B as well. So you can end up with this formula. A over sine A is the same as B over sine B, or if you want, that's C over sine C. Although the C here can be confusing, so we'll just maybe write it like this. Or another way people write it is upside down. Sine A over A equals sine B over B, which equals sine C over C. It doesn't matter. This rule here, this is called the sine rule. And let me show you how to use it in a moment. So this is called the sine rule. And it works for any triangle. Questions? No? I'm sure many people have seen this before. No? Or yes? Seen it before? Yeah. And you also called it the sine rule? No? Okay. The something rule.
Has no special name.
No special name. Alright, fair enough. Okay. Can I show you an example of this? So we have a triangle. Let's say this is 5, and this is 8, and this is, well, let me make it a bit different. Let me draw that again. Let's say this is 30, and then this is 6, and then this is 40, and this is 8, something like that. Did I give you too much information? I only need to give you 3 things. I gave you 4 things. Yeah, actually I gave you too much. Yeah. And we're looking for this side. Well, I don't know if it's 8. We'll have to calculate it. I don't think it will be 8. That would be an amazing guess if it was 8. Okay. Yeah. you need to have three pieces of information. So in this triangle, I have two angles and a side. But it could also be two sides and an angle. It doesn't have to be just like this. That's not 40, is it? No. Oh, 140. That's better, it's big. Okay, so you have to have three pieces of information. Here is two angles and one side. So let me call this side here x. So what you do, watch carefully, is you take an angle and you match it with the opposite side. And you say sine 30 over 6 must equal, and then you take an angle and you match it with the opposite side. Sine 140 over x. Or if you want, now, let me just rewind back in time. You could have done it the other way around. You could have said, take a side and match it with an angle. So you would have 6 over sine 30. Take a side and match it with an angle. Equals x over sine 140. Both will give you the same answer. This one is a little easier because you can just bring that up. So you get x equals sine 140 over sine 30 times 6. So let's see what we get.
7.7.
Not bad guess. I thought it would look like an 8. Sine 140 divided by sine 30 times 6, and we get 7.7. Not so bad. So that's how big the x side is. So we need two angles and a side, or two sides and an angle. What's nice about the sine rule is it works for lots of different triangles, but it doesn't work for every triangle. Let me show you an example of when it doesn't work. Can I go down? Yeah? No. Yes. And what's also nice about this formula is it's not so difficult to use. It's straightforward. Yeah? Can I go down? Is that a yes or a no? It's yes. So let me show you an example of when it doesn't work. I don't know. 5, 6, 7. Here it will not work. Even though we have three pieces of information, it won't work because what will happen? I'll have to match a side with an angle, so I'll call this angle A. So we have 5 over sine A. And then I have to match a side with an angle. I don't know this angle, so I'll call this angle B. So that would be 6 over sine B. And then we could say equals, if we want, 7 over sine C. It's not working. The problem is we don't know any of the angles. So you need to have at least one angle. And also another situation where it'll definitely not work is like this. If we know all the angles. Is there any way to know the sides here? No, it's impossible. It's impossible. So we need to have at least one side and at least one angle to use the sine rule.
Because it can be any number.
Yeah, it could be anything. Pick your favorite number.
4.
Okay. Could be anything. Yeah? Anything except,
0.
well, yeah, 0 or negative numbers maybe. Yeah? Okay, so we need another rule. Sine rule is great, but it doesn't work all the time. We need a second rule. So no surprise here. The second rule is called the cosine rule. Okay, can we have a look at this rule now? Yes? Ah, so much whispering. What's
Ask for setting name for it.
for cosine?
No, for sine.
For sine.
Sine rule. Sine rule. That is sine
Does
rule.
it translate the same way? Sine rule? Direct translation? Yeah. Anyways, why do you need it in Chinese? The test is in English. So, you don't need to know it in Chinese for the test. You just need to know it in English. Okay, so we take another triangle. Again, maybe right angle, maybe not. Come on, guys, come on, are we listening? Yes? So we'll call this side here, let me just draw that a little neater.
Is that?
Yeah, it is still bad, but it's not as bad. Left triangle. Come on, you all have the internet, don't you? Yeah? Great. Okay. Oops, knocked off again. Come on. Come on. My triangle was so bad, broke my laptop. There we go. Okay, so we'll call this side here A, and this side here B, this side here C, this is A, this is B, and we'll call this side here C. I think I remember the proof. So, first thing we do, a bit like with the sine rule, we draw a straight line down here, like that. But what's a little bit different now, instead of calling this the H, we call this side here the X. So this here is X. So how big is this side? If the total is C, and the piece on the left is X, C minus X for this piece. Okay, so draw that so far, and then we'll do the next part. Oh, and of course, this, I'm making it 90. Yep. Now we don't look at sine this time. This time we look at Pythagoras. So actually I guess I do have to call this H still. So we have x squared plus h squared, let me write that again, x squared plus h squared equals b squared. Because I'm looking at this triangle here. Now I'll have a look at this triangle. So by using Pythagoras again, I get c minus x squared plus h squared equals a squared.
And you had x, c, x plus.
Yeah, what to do next, do you think? What do you think might be the next step? So which thing do I not like in my formula here? I like the A, B and C because I'm given the A, B and C. I don't like what? I don't like the X and I don't like the H because I introduced them. Now I can't do much about the X right now, but I definitely can do something about the H. What's that? If I want to get rid of that H, if I want to cancel the H. Subtract, yeah. If I just do a subtraction here, I have x squared minus c minus x squared equals b squared minus a squared. Okay, so let's clean this up a little bit. I don't really want the minus there, but I'll take care of that later. I'll have x squared minus bracket c squared minus 2cx plus x squared bracket equals b squared minus a squared. X squared minus c squared plus 2cx minus x squared equals b squared minus a squared. What's nice is that these cancel. So again, I don't want to deal with minus. So what I'll do is I'll move things around. I think I'll take this to the right, and I'll take this to the right, and I'll take this to the left. So I'll have a squared equals b squared plus c squared minus 2cx. So we're doing quite well. We only need to get rid of that x. So to be clear, I took this one to the right, it becomes plus. I took this one to the left, it becomes plus. I took this one to the right, it becomes minus. Okay, any ideas about the x now? What can I do about the x? Any ideas?
Same time.
Yes. It's called the cosine rule. Yeah, so we have to use cosine. If I go back here, I can say cosine A equals x over b. So that means x equals b cosine A. This will be very useful now. So if I use this result down below, I get a squared equals b squared plus c squared minus 2c. X is b cos A. So I can clean this a little bit. I can say a squared equals b squared plus c squared minus 2bc cos A. There are other ways to write this result. Let me just show you in case you see it. You could also say b squared equals c squared plus a squared minus 2ca cos b, or you could also say c squared equals a squared plus b squared minus 2ab cos c, but it's the same thing as this. This is the cosine rule. Okay, so make sure you carefully write this down. Whoops. Got this? Let's have a look at an example. Yes? Example? Albert. What do you think I'm going to say? No. Try again.
Example.
Something. Put the phone away. And you can use that calculator, okay? Thank you. Okay, examples now. Can I scroll down? Yep. Yes? Okay. So let's look at an example of using the cosine rule. So we have our triangle. And one example would be if you know two sides and an angle. And you might think, oh, I can use the sine rule here. You can't really, I mean, you could try to use the sine rule, but the cosine rule is definitely quicker here. When you want to find this side here, x. Sine rule doesn't really work. It's another example of when the sine rule doesn't work. So the cosine rule, the way you work the cosine rule is you need to have two situations. An angle, a side, and an angle between the sides. Or the other time you can use the cosine rule is when you have three sides and no angles. So let's do two examples. Let's do this one first. So the cosine rule is a little bit like Pythagoras. It's a little bit like Pythagoras. You start with the side you don't know. This is like the A. And you say x squared equals 6 squared plus 7 squared. Now, so far this looks like Pythagoras, right? Doesn't it look like Pythagoras? Yeah. Except this is where it's different. You then say minus 2 times 6 times 7 cos 30. So it's just like Pythagoras, except you have this extra piece at the end because it's not a right angle. Okay, so we'll just type this into the calculator and let's see what we get. 6 squared plus 7 squared minus 2 times 6 times 7 times cos 30. Square root the answer. So I get x is 3.5. Got this one? Yeah. Can I go down to the next one? Not yet. I can go down? Yeah. Okay. So let's say we have a triangle like this. 3, 4, 6. And let's say I want to find the angle between the two smaller sides, x here, or something like this. So I can use the cosine rule. Again, like Pythagoras, except just remember, we usually start on the side which is opposite the angle. So we can say 6 squared equals 3 squared plus 4 squared minus 2 twice 3 4 cos x. So I have 6 squared minus 3 squared minus 4 squared over minus 2 3 4. That's equal to cos x. Let's have a look. 6 squared minus 3 squared minus 4 squared over minus 2 3 4. So I get cos x equals minus 0.458. So when you solve that, you get x equals 117 degrees, which if you look at the picture, it should be more than 90. I know my picture's not great, but it looks like it's more than 90 because it's opposite a long side. Yep. Okay, so the reason we're doing sine and cosine rule is because for this question and for this exam, you're going to have to use these for practical problems. So I'll give you an example of a practical problem. Have we got this?
No.
Not yet? Okay? Go down? Yeah. So what happens in the exam, they usually give you a story or a picture or something like this. So here's my picture. So grass, and then building. It's a building. And then what happens here is in the story you have your person stands here and they look up or they measure up from the ground. They put some instrument on the ground, and then they point it to the top of the building, and they can measure the angle here. So maybe they measure this angle as 20, let's make it realistic, let's say 40 degrees. And then they take one step forward, or 2 steps or whatever, so they know maybe that this distance here is 2 meters. And then they measure the angle again, so the angle goes up to the top again, and this angle will be bigger, it will be 45 degrees. So in fact, there is enough information here to work out the height of the building. Now, I'm going to let you try this before I do it, and I'll give you a small hint. Right, listen, hint. So my hint is, before you find H, you should find what this side of the triangle is. And we should think about this as 2 triangles. A triangle here and a triangle here.
How did you know it's like 45?
Oh, this is in the question. But in real life, there's a little machine, very simple machine that you can use, and you can point it at something, and then you can measure the angle. Clinometer is what it's called. It measures the angle when you look at something. Yeah. So 40 and 45 can be measured easily, and of course the 2 meters can be measured easily if he has a meter stick. Okay. So this information is easy to get, and you can use this to work out the height. So what I want you to do is calculate the H. And my advice is first calculate the X. Then you can get the height. Okay, so try this for a couple of minutes before I do it. And if you want another hint, the very first thing you should do is you should write in all the angles. Because if you know this angle, you can know this angle. If you know this angle, you can know this angle. If you know this angle and this angle, you can know this angle. Finished?
No.
Some people are. I've seen this exact problem in the exam twice. Finished? Okay, ready to look at it?
No. It's
No?
still working.
Okay, another minute or two. You got an answer? What did you get?
2.7.
that looks about right, I suppose. What did you get?
1.42.
Yeah, it's quite different.
10.42.
Oh dear.
Oh my god.
10.43. 43. I got 10.43.
Oh, this is looking very bad for you. Let's have a look at it. Well, maybe they're all wrong.
Oh no.
You don't think so? Okay.
Yeah, I'm sure.
Maybe. Let's look. Alright, so firstly, what's the angle here?
Um, 135.
135 because the total must be 180. And what is the angle here?
5.
5 because the total must be 180. Now if this is 45 and this is 90, then this here must be 45 because the total must be 180. Should I use the sine rule or the cosine rule on this triangle? Yeah, I should use the sine rule. I should say 2 over sine 5 equals x over sine 40. So x equals sine 40 over sine 5 multiplied by 2. Now, I won't type that in yet. I'll keep it like this to be more accurate until the end. But we know the x. Now, if I look at this triangle here, you know that sine 45, this 45, what will that equal?
1.
True,
No,
it is.
just 1.
No, it is 1, but in the triangle, oh no, it's not 1. In the triangle, it'll be h over x, won't it? Because it's right angles. You can say sine 45 is h over x. So then h equals x sine 45. Do we know what x is? Yeah, we got it 1 minute ago. So our answer is h equals 2 times sine 45 times sine 40 all over sine 5. What I did was,
5, not 50.
yeah, I said 5. Why did I write 50? All I did was I took this for the x and put it in here. So this equals, let's see what we get. 2 sine 45 sine 40 sine 5. Bad news.
I know.
10.43. What was your problem? Huh?
It's a square.
Oh, you use Pythagoras.
Yeah.
Ah, yes. Yes, yes. And the square. Yes, 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 yes. Okay. Write this one down. I've seen this in the exam twice, but maybe even 3 times. 3 times in the last 8 years is pretty common for an exam question. So this is an important example. Okay. Have you got this? Yes? Okay.
This is good for our project.
No. Project has nothing to do with trigonometry, sorry. Are you saying it is good or it would be good?
Yeah, it's good.
Too easy. Okay. Continue? Yeah. Okay, so let's do another example, a little bit more difficult. Okay. Okay, so boys' rope is 15 meters long, and then the girls' rope, you know, like what's rope? You know, like string to pull yourself up. I don't know what a rope is. Yeah. You know rope, string. Here, rope. This is rope, like this. Yeah. So the boys' rope is 15 meters long. And the girls' rope is 13 meters long. And the boys' rope is at an angle of 53.13 to the ground. And then the girls' rope is at an angle of is at an angle of 67.4 degrees to the ground. So the reason each of them has a rope is because they are keeping a balloon in place. So what I mean by that, if I draw it, there's a big balloon and it's trying to float away. So they're on the ground. There's the boy and there's the girl, and they each have a rope. They're trying to hold the balloon in place. So the boy's rope is 15 meters long and the girl's rope is 13 meters long. The boy's rope makes an angle of 53 with the ground, and the girl's rope makes an angle of 67 with the ground. You get the picture? Yeah. So first thing I want you to do is to draw this, and I want to see what you draw. So let me just fix that up. I give you 4 pieces of information. Boys' rope, girls' rope, boys' angles, girls' angle, and here is the balloon that they're trying to stop. So this is floating up, so they need to put their ropes on it to hold it. So I want to see what you draw, and I want you to write the numbers and the angles in.
Are you asking for the basics?
No, nothing right now. I just want to see what you draw.
I have to use glasses.
Can you draw it again, but with stick people and a balloon? Because I don't know which way is which. Yeah, so draw a bit of... Oh, yes. Little people, please, and a balloon will help me picture it. Yeah? Okay, good. What's that? No. I think you're confused. What did you draw? Now, where's the boy and where's the girl? No, where does the boy stand? Yes. And here. And where's the balloon? Yes. Where's the balloon? Balloon is here. You know balloon? Okay. It floats. Hot air floats. At a party. Birthday party. Balloons, they float. I know balloon. And it has a little string here and it floats away. You know? I think you know. Yes. And the balloon? Okay, can I see yours? No, can I see yours? Yes? Yes, okay, so we all have the idea here. So let's draw that. Okay, so I think everybody has the idea. Here's the balloon. And here's the boy here. What angle is this? 53.13. And this length? 15 meters. Yes? And then the girl is here, and she must be closer because her rope is 13, yeah. And the angle here? 0.4. Now, suppose you were right, by the way, I was asking for the base. So suppose I was to ask you for the base, that means I want to calculate this. Wait, now before you do it, what rule could you use here? What would be the best rule to use? Cosine rule, because you can very easily know this angle. And as soon as you know this angle, cosine rule really quick. So I'll give you, should only take you like 1 minute, 2 minutes maximum. Get me the x please here. And I'll even get the angle for you. So this angle in here is 59.47. Did we get an x? Yeah? Yeah, so let's see what we get. We have x squared equals 15 squared plus 13 squared minus twice 15, 13 cos 59.47. So then when you work that out, 14 exactly, isn't it? Seems simple?
Yeah, 14.
But there are two answers here. This is only the first answer. There are two answers here. You can see how? Yeah, what? What do you think needs to happen?
Is that inside of the...
Yes, very good, very good. So we could have drawn it this way. Watch. If I go back in time, I could have put the girl beside the boy of 13, and this angle here is, what was it, 67.4. So if I draw the triangle, it looks like this now. This side is 15, this side is 13. This angle is 53.13. Sorry, I'm getting a bit cramped here. And this angle here is 180 minus 67.4. 112.6. 112.6. And then this angle here, I can know it, is 180 minus that minus 53.13. So this angle up here is 14.27. What rule do I use again? Cosine rule again. This time I say x squared equals 15 squared plus 13 squared minus twice 15, 13 cos 14.27. So when I type this in, I get x is 4. Now the reason I did this is because sometimes in the exam and in your calculations there are two possible answers, and often you need to decide from the question which answer it is. Okay, so I mean here, it's probably the first one you drew, although I don't have the question, but if this was an exam question and they drew the picture for you, then you can definitely know which one it is. But if they didn't draw the picture, there must be some other information in the question that lets you decide between the two possible pictures. So, what might they say in the question that makes you pick the first picture? Yeah, no, something more, less mathematical, something more like just general English. What could they say?
They are facing each other.
Yeah, you could say they're facing each other. Then that means it has to be the first one, really. Whereas in the second example, they are not facing each other. They're both kind of pointing to the right, looking up at the balloon. So you're right, you could say facing each other, or you could say opposite each other. In the first one, you could say they're opposite each other, but you can't say that in the second one because they're beside each other. So this is what I mean. For this lesson, the English is very important. You have to read the question carefully. And sometimes only one word is all that makes a difference. So here, if I said they are beside each other, or if they are opposite each other, that changes the picture. And as you can see, that makes a big difference in the answer. Now in the exam, it's usually not like this, which is good news. In the exam, it's usually clear, but it is possible that you could get two answers in the exam, and you need to choose carefully. There's usually only one answer. Yeah. Now, if you look at this page, there's basically two problems. The first here is just to practice the sine and the cosine rule, and I definitely don't need you to do all of the table. So you could just do something like in the table, like number, what was that? 1, yeah, that's okay. And
Number 2.
no, number 2 is nearly the same as number 1. I want something 1,
19.
4,
26. Yeah. Oh. And the
sure, 19. Why not? 1, 4, 19, and spread. Wait. Now, do you see these questions 2 to 9? Yes. Oh? Huh? That's a good idea. No, seriously, these are all exam type questions. They're all practical problems. And most exams have one of these questions. And they will drive you crazy. But you need to do them now. So you can work on them for 5 minutes, okay? So 1, 4, 19 in the table, and then 2 to 9.
For tomorrow?
Yeah, because there was no hope.
No, Friday.
No.
Is your economics due tomorrow?
Yes.
Or the next class after tomorrow, which is when's that?
Friday.
Wednesday, Thursday?
No, Friday.
Wednesday. Wednesday is plenty of time because you probably have the homework finished from the first lesson, yeah? Yes. So look, start them now for 5